Okay, so here we have International Pearson's question, second question on the paper. It's June 2015, I think this question's from. These questions are normally quite nice to do, so let's just get on with it. A few things. We've got the velocity given, so if we want acceleration we need to differentiate. If we want a position vector or displacement we need to integrate. There's a bit more to this one because it's saying at when t equals to 1, it's given us a position vector, but more importantly, if we go to the question for part A, it talks about the magnitude of the acceleration when it's moving in the direction of the I vector. Well, when is it moving in the direction of the I vector? Well, it's the velocity that's going to determine that. So let's work that out first. And then we can differentiate the velocity and substitute into the appropriate value t into there. So it'll be parallel to I when j component equals to 0. Equal to 0. So that's basically this bit here. 8 minus t cubed equals 0. So that gives us t cubed equals 8, t equals 2. Okay, that wasn't too bad. So what we're going to now do is substitute our value of t into our acceleration vector. Now to find the acceleration, we just need to differentiate the velocity. And we need to differentiate each bit. So we've got this bit, the 27 just goes, so that's minus 6t I. 27 disappears when we differentiate, and similarly the 8 disappears here, but we're left with the minus 3t squared times j. Now substituting our value of t, our value of t is 2, so the acceleration is equal to minus 12i, putting 2 into there, and minus 12j, putting 2 into there. Better say what we're doing here just in case it's not clear. So when t equals 2 we have acceleration is that, but do be careful. A number of people miss out on by not answering the question. It does ask for a magnitude, so given the acceleration vector is not fully answering our question. Okay, so I'm not bothering with negatives when we work out negatives. Obviously we know the magnitude, it doesn't matter which direction the i's and j's are, so it's 12 squared plus 12 squared. Working with surds, pretty easy to see that that is going to be 12 the square root of 2. That's actually acceptable in the mark scheme as an answer. If you want to be careful, if you do want to work it out just to be safe, give 3 significant figures here. Okay, so that's part A done. Part B. Part B is talking about a position vector, so that's obviously talking about integrating. So our position vector is going to be the integral of v dt, so that equals to, let's just do each component, 27t minus t cubed I plus 8t minus a quarter t to the 4j, but don't forget, because we're integrating we need a constant, and because we're dealing with vectors here, our constant is going to be a vector, which effectively means 2 unknowns, or c1 and c2. Right, okay, we can work that out easy enough for what it's told us up here. T equals 1, r equals this. So when t equals 1, r equals that, so we can say, we better write that. Do tell people what you're doing in your work and in your writing. And just leave us guessing. Okay, so we're saying when t equals to 1, r equals to minus 5i plus 2j. So we've got minus 5i plus 2j equals, and we can sub 1 into these. Subbing 1 in is quite nice and easy. I think we can just do that without too much problem. 8 minus a quarter plus c1i plus c2j. Now a little bit of fiddling around here gives us, if I move it this way around, so these are just taking care with signs and just looking at it. I can see I've got plus 27 here and I've got minus 5, so it's minus 31i. As far as the j's component of j goes, I've got plus 2 here, and I've got, that's 8 1/4, which is going to be 7 3/4. So I'm taking away 7 3/4, which effectively means minus 5 3/4, but we don't like top heavy fractions. So that's minus 23 over 4j. So now we can write our position vector, a general position vector in with our constants in. Might as well incorporate it into our I and j bits now. So now it's just a matter of subbing when t equals to 3. Doesn't want a distance. This time doesn't want a magnitude. This time it's happy to have a vector. So r equals to 27 times 3 minus 3 cubed minus 31 I plus 8 times 3 minus a quarter times 3 cubed minus 23 over 4j. So r equals, let's work this out carefully, 27 times 3 minus 27 minus 31. Again, that's 23i. And this here is 8 times 3 minus 27 divided by 4, is what I'm keyed into my calculator at the moment. I don't want to be typing fractions in. Minus 23 divided 4. 23 over 2. Ah, there is a mistake. There we go. It didn't feel right. That was, if you remember that was t to the 4. So that's to the 4. It's very strange. I changed it from a squared to from a 4 to a squared to a cube. So anyway, we've got a 4 there. Let's try again. So that's 8 times 3 minus 27. 81 divided 4 minus 23 divided 4, which is equal to minus 2. And that's our answer. Thank you very much.